My dear students of 11th class, and today in your botany, we are going to take up another topic and very important in our plant physiology, that is the water potential. And previously we have discussed about the importance of the water in case of the plants, or in terms of plant physiology we say the plant water relations. And you must be remembering those all importances which we discussed in the previous class. And today we will take up the water potential. Stay keen and listen carefully. This water potential, just to comprehend plant water relations and understanding of certain standard terms is necessary. In this regard, the most important term here is the water potential, which is denoted by the Greek symbol psi and a small w in the subscript written at the base of this symbol psi. Water potential is a concept fundamental to understanding water movement. So, this water potential is a concept. This is basic in order to understand the water movement inside the tissues of the plant. A solute potential, which is denoted by psi and subscript s, and also the pressure potential denoted by psi p, are the two main components that determine water potential and which are important for determining the water potential, that is the solute potential and the pressure potential. Water molecules possess kinetic energy. This you must be knowing. In liquid and gaseous form, they are in a random motion, that is both rapid and constant. The molecules in the water, they move rapidly and in some cases constantly. And the greater the concentration of the water in a system, the greater is its kinetic energy or water potential. This is understood. The greater the concentration of the water in a system, the greater is its kinetic energy or water potential. Hence, it is obvious that pure water will have the greatest water potential. Now, if two systems containing water are in contact, a random movement of the water molecule will result in a net movement of the water molecules from the system with a higher energy to the one with lower energy. As you know, there is a movement of the water molecules from the system. Or in case of diffusion, you have seen that the molecules move from a region of higher region concentration to the region of lower concentration. And here in case of the water movement, the movement of the water molecules from the system with higher energy to the one with lower energy. Thus, water will move from the system containing water at higher water potential to the one having the lower water potential. This process of movement of substances down a gradient of free energy, this is called as diffusion. Here is the term diffusion is again used. Water potential is denoted by the Greek symbol, as I have already told you, psi, spelled as psi, or its symbol is like this and is expressed in pressure units such as pascals, abbreviated as PA. By convention, the water potential of pure water is at standard temperatures, which is not under any pressure, is taken to be zero. Again, the water potential of pure water at standard temperature, which is not under any pressure, is taken to be zero. If some solute is dissolved in pure water, the solution has pure free water and the concentration of the water decreases, reducing its water potential. Hence, all solutions having a lower water potential than pure water The magnitude of this lowering due to the dissolution of a solute is called the solute potential, denoted by psi s. This psi s is always negative. The more the solute molecules, the lower is the solute potential. For a solution at atmospheric pressure, water potential is taken equal to the solute potential. Water potential is equal to solute potential. Now, if a pressure gradient greater than atmospheric pressure is applied to pure water or a solution, its water potential increases. Again, if a pressure greater than atmospheric pressure is applied to pure water or a solution, its water potential increases. It is equivalent to the pumping water from one place to another. Now think of any system in our body where pressure is built. Pressure can build up in a plant system. When water enters a plant cell due to diffusion causing a pressure built up against the cell wall, it makes the cell turgid. And now this increase in the pressure potential, this pressure potential is usually positive, though in plants negative potential or tension in the water column in the xylem plays major role in water transport up a stem. A pressure potential is denoted as psi p in the subscript. Water potential of a cell is affected by both solute and pressure potential. The relationship between them is as follows. Water potential denoted by psi subscript W is equal to solute potential plus pressure potential. And this is all for today. Have a nice day. Take care.